Hello class, welcome to the lesson homework video. So I'm going to go over the 2.3 homework problems from Savas. So let's start with the first one. Here we have an arrow analysis question. So on a math test, the students are given a right triangle. One of the acute angles has a measure of 28 degrees. One student says that the measure of the other acute angle is 152 degrees. What is the measure of the other acute angle? What error could the student have made? So basically, the student knew that you had 28 degrees for one of the angles in this triangle. And so he said, okay, well, they had to add up to 180. So 152 plus 28 is 180. Done. That's my other angle, 152. But what the student failed to realize is that there was a third angle, right? The third angle in a right triangle is 90 degrees. Remember that a right triangle is a triangle with a 90-degree angle. A right angle is 90 degrees. So because we have a right triangle, one of the angles has to be 90 degrees. And they said in the problem that the other angle is 28 degrees. So what is the third angle? Well, remember, according to the triangle angle sum theorem, all the angles in a triangle have to add up to 180. So if I wanted to figure this out, well, we'll call that x. Well, I know that these three angles have to add up to 180. So x plus 28 plus 90 has to equal 180. And so we can figure out, well, if we add these two together and we subtract it from 180, we should get the other angle, right? We have x plus, let's add these up together, 118. And so these two angles add up to 118, so then this has to make up the rest, right? So we'll subtract 118 on both sides, and that gives us the rest. So we have 62 degrees. That means that other angle has to be 62 degrees. And so we'll say that the student made a mistake for sure. It's definitely not 152. It's more closer to 62 degrees. That's the first example. So now let's look at a proof example. Proof of the exterior angle of a triangle corollary. Fill in the missing steps of the proof. So basically, we want to prove the exterior angle triangle theorem that we mentioned in that lesson. In this case, to call it a corollary, we want to prove it. So we got a triangle with an exterior angle, angle 1, and we want to prove that the exterior angle, you get the exterior angle by adding your two remote interior angles, which is what we talked about in class, but we want to prove that. And so the first statement is, well, it's an exterior angle, right? Angle 1 is exterior angle because that's given. And so now the next theorem here is, well, next step here, well, we said that 1 and 4 have to add up to 180. So why is it that 1 and 4 adds up to 180? Well, that's because they're a linear pair. If you think about it, remember, a linear pair, should they share a side, right? They're part of a line. They have both sides of the same line. They share a side. They're next to each other. And you notice that they add up to 180 because they're in a straight line. And so that's a linear pair. So linear pairs add up to 180, also known as angle addition postulate. So let's go back to the example, which was example 2. And see what this is about. So it says here, same problem. So let's go ahead and look at the answer choices. So angle 1 and angle 4, they're a linear pair. We can also we can also call this angle addition postulate or a straight angle. A straight angle is basically what it sounds like. It's if it makes a straight line, and a straight angle is 180. And so we can say that that's the definition of a straight angle using the angle addition postulate. Okay, so remember, straight angle is an angle like this that is 180 degrees. So if you see a straight line, well, that's just 180 degrees. And so if you see two angles that break this up, well, then they have to break up the 180, right? So if this is 30, then this has to be 150 because it has to add up to 180 for a straight angle. All right. So now looking at the next step, well, they said that the reason is the triangle angle sum theorem. So what is that theorem? Well, that theorem states that these three angles in the triangle have to add up to 180, right? So we're going to go ahead and say, well, 2, 3, and 4 have to add up to 180. That's the triangle angle sum theorem. Okay, so now next what they say is, well, because they're both equal to 180, right? That's equal to 180. This is equal to 180. And therefore, these two things have to be equal to each other because they're both equal to the same thing. And so if if A is equal to B and B is equal to C, then A has to equal to C. So let's write that out. So and let's do this off to the side. So if A equals B and B equals C, well, then that means that A has to equal C by logical consistency. They have to be equal to each other, and so that's called a transitive property. So we're going to be using that transitive property in this step here. So otherwise, sometimes they'll call it substitution. So you can also think of it as a substitution because you're thinking of A as being equal to B, and basically you're replacing B with A. And so therefore B is now replaced with A, and so A equals C. So you can also think of it as a substitution. But sometimes it's called the transitive property. But in this example, they use substitution for steps 2 and 3. So go ahead and check the answer here. And then the last step here is basically taking the previous steps, or basically taking the fourth step, and because we know that they're equal to each other, let's go ahead and write this out. It's easier if I write it down here. So we have angle 1 plus angle 4 is equal to the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4. And so what we want to do is we want to get rid of the measure of angle 4 by subtracting it on both sides, because it's the same thing on both sides, so we can cancel it. And therefore, we're left with angle 1 is equal to angle 2 plus angle 3, which is what we would set out to prove. And so this property that we used here is known as the subtraction property of equality, when you're subtracting the same number on both sides. So that's the property that we're using here, subtraction property of equality. All right, and we've set out, and basically we proved the corollary. We proved the theorem here. So now let's look at the next question. So here, use the given information to find the measure of angle A. So we have this triangle here with exterior angles, and they tell us that angle D is 117. So this is 117 degrees. Angle A is 2x. And angle B is x plus 19.5. Okay, so basically, we got to figure out something that helps us find x here using these relationships. Well, we know that this angle right here, that is an exterior angle. Okay, so because that's an exterior angle, we know that the exterior, remember, has to equal the sum of the remote interiors. So exterior is equal to remote interior plus remote interior. Okay, so what are the remote interiors here? Well, we got the exterior. The remote interiors are the interior angles that are farthest away, opposite of the opposite of this angle. So it's not going to be angle C, because angle C is not very far away from D. It's going to be these two, the farthest away inside the triangle. So in this case, it's angle A and angle B, but we know what those are. It's those guys. So the exterior angle, which is 117, has to equal the two remote interiors, which are in this case 2x and x plus 19.5. So those are my two remote interiors. So now we can combine like terms. 2x plus x is 3x. We have 3x plus 19.5. We just bring that down. Bring this down. Let's subtract the 19.5 on both sides. So 117 minus 19.5. Not going to do mental math there because I will probably mess it up here. So we got 97.5 is equal to 3x. We'll divide by 3 on both sides. So we get 32.5. So x is 32.5. All right, and that's my value of x here. Now we want to figure out what angle A is, right? So remember that angle A is 2x. So we got to plug in the x there. So the x that we found here has to be plugged in there. And so we get 2 times 32.5. That was the x value that we found, which in this case is 65 degrees. So angle A is 65 degrees. This example. All right, so let's look at another example. Find the number of degrees in the third angle of a triangle. So we have a triangle here, and we want to figure out the third angle. Well, this one's not so bad. 3 angles in a triangle have to add up to 180, right? So we have x plus 49 plus 92 equals 180. They have to add up to 180 by the triangle angle sum theorem. So we add those together. This is going to be 141. And then we subtract 141 on both sides, so solve for x. So x is equal to 39 degrees. All right, so that's x. X is 39. All right, so that problem's done. So a company is making different size statues that are in the shape of hourglasses. Use the figure to find the missing measure x. Okay, so we just want to figure out what x is. Well, these 2 angles right here, these are vertical angles. Remember, vertical angles are angles that are formed by intersecting lines like this. There are 2 lines that intersect, and they're the angles opposite of each other in that railroad crossing, if you will. So another set of vertical angles would be, for example, these 2, the ones in green. So those are vertical angles, and the ones in red are vertical angles as well. Vertical angles are always equal to each other. So if this is 69, then this is going to be 69 degrees as well. And so now, if we look at the triangle right here, this blue triangle, well, we know the angles have to add up to 180, so we can figure out what x is. So we have 62 plus 69 plus x equals 180. We do it like we did in the previous problem. We add these together. We have 131 plus x equals 180. We'll subtract 131 on both sides. So x equals 49 degrees. Okay, so x equals 49. And that makes sense according to that problem. They add up to 180. And so you're just going to type that in to Savas. All right, so let's look at the next problem. For the figure shown, find the measure of angle 1. So let's go to the figure. So we want to figure out what angle 1 is. This is an exterior angle problem. Remember that we said that exterior has to equal to the sum of the 2 remote interiors, the ones that are farthest away. So exterior equals sum of the remote interiors. So 61 plus angle 1. This is not an angle measure. This is saying that this is angle 1. We don't know what angle 1 is. We're trying to find it. So the measure of angle 1. How do we know? Well, it's indicated by degrees. If it says degrees, then that's telling you that that's the measure. Okay, so now we can solve for the measure of angle 1 by subtracting 61 on both sides. So 123 minus 61 is 62. So 62 is the measure of angle 1. All right, see, those problems don't take very too long as you know what's going on. So for the figure shown, find measure of angle 1 and angle 2. So this one's a little bit different, so let's look at this problem. This one is another exterior angle measure, but here's what we need to look at. So here we have, to figure out what angle 1 is, what you want to do is you want to use this triangle right here. You want to use that triangle for angle 1. Because if you use that triangle, well then you see, well, you just have something that looks like that. And we know that this is an exterior angle. Remember that exterior angle is equal to the sum of the remote interiors. Well, these are the remote interiors. So 99 and 32. So if we add those 2 remote interiors, that should equal the exterior. So the measure of angle 1 has to equal the sum of the 2 remote interiors, 99 plus 32. Which is, in this case, it's just going to be 131. So angle 1 is actually 131 degrees. Now, if they want to figure out angle 2, well, you're going to have to use a different triangle, right? You're going to have to use let's erase this, and this time we'll focus on using this triangle right here. So if we use that triangle, well, we get this, right? Well then, if you notice, well, this right here is my exterior angle. That's my exterior angle right there, and that's angle 2. So the exterior has to add up to my 2 remote interiors. Which are these guys, the ones that are farthest away in that triangle. So we got the measure of angle 2 has to equal the 27 degrees plus the measure of angle 1. But we know what angle 1 is, don't we? We found it here. So we can plug that in. So really we can make a substitution and say that's just 131. So angle 2 is 27 plus 131 is 159. All right. For the figures shown, find angle 1 and angle 2. Same deal. We're going to do the same kind of problem. So here we have focusing on this triangle right here for a second. Well, we know that that's an exterior angle, and these are my 2 remote interiors. So I know that 130 has to equal measure of angle 1 plus 16 degrees. And then if I subtract 16 on both sides, well, then I get angle 1. So the measure of angle 1 is 120 or 114. Okay, so we know that this is 114. So now let's look at another triangle. So now let's look, if we want to figure out angle 2, let's look at this triangle. Right there. If I look at that triangle, well, now we got an exterior angle right here. This exterior angle is 114. Because we found it earlier, right? Well, it was 114 right here. And the remote interiors are 87 and angle 2. So we have here 114 is equal to 87 plus the measure of angle 2. So we can solve for angle 2 by subtracting 87 on both sides. And we have the measure of angle 2 is equal to, that's going to be 24 degrees. All right, and those are my 2 angles for that problem. All right, we are hopefully wrapping this up soon. We have here, for the figure shown, find angle 1 and angle 2. Oh, I think didn't we do that? Yeah, we did something very similar. So I'm not going to do this one. This is actually the same type of problem as this. So I'm not going to do the same type of problem. They just have different numbers. So it's extra practice. All right, so we'll skip that one. Look very similar. So let's look at this one. So it says a ramp forms the angles shown to the right. What are the values of A and B? So we got an exterior angle right here. This right here is my exterior angle, right? And so, okay, well, we know that this is a right triangle. If we look at this triangle right here, well, that's a right triangle. So this right here, that's 90 degrees. So if that's 90 degrees and this is 67, well, we know that all the angles in a triangle have to add up to 180. So 90 plus 67 plus B, these 3 angles have to add to 180 because it's a triangle. And so we get 157 plus B equals 180. Subtract 157 on both sides. So B has to be 23 degrees. So now we know what B is. This is 23. Now, because we know that's 23, well, we know B is 23. And so now let's find A. So now A, remember, is an exterior angle. So to get A, to get the exterior angle, you have to add the 2 remote interiors, right? So A, which is the exterior, has to equal 90 plus 67, the 2 remote interiors. And so that's going to be 157. So that's A and B. You can also get A from B directly because we know that if this is A and this is B, well, they form a linear pair. They form a straight angle. And so if you know that B is 23, well, then A has to be 157 because they had to add it to 180. So that's another way to do it. But I wanted to do it with the theorems that we talked about in class, aside from just straight angle. Okay, so what are the values of x, y, and z for this triple triangle scenario? All right, so let's do x. We have here a triangle. We're focusing on this triangle with this exterior angle. That's an exterior angle, so we'll do that in red. The exterior angle is equal to the sum of the two remote interiors. So x is equal to 66 plus 45. So x is equal to 111. All right, so x is 111. So now let's focus on another triangle. So now we want to get angle y. And so to get angle y, what I'm going to do is I'm going to focus on second triangle and then this exterior angle, 66. So now 66 is now my exterior angle for that yellow triangle. So we have 66 is equal to my two remote interiors, y plus 30. And so if I subtract 30 on both sides, well, y has to be 36. So we got 36 for y. So now let's look at another triangle for z. Now we're looking at this triangle and this exterior angle. You can also look at this exterior angle, or actually that's not an exterior angle. This will not be an exterior angle to this triangle. You got to be very careful with that. An exterior angle, so something is called an exterior angle if when you take that side, you extend it, right? You have to literally extend that side to get an exterior angle. So that would be the exterior angle for this. Now, if I were to extend this side, then this would be the exterior angle for that side. If I were to extend the other side, this would be the exterior angle to that side. But I cannot have some kind of scenario where it's like, for example, like this, right? Where it just sticks out off to the side and it's not an extension of anything, right? So that's not something that you can do. Well, this is an extension, so I can use that. So this right here is an exterior angle. So 119 has to equal the sum of the two remote interiors, which are z and 43. So subtract 43 on both sides, we get z is 76 degrees. All right, we're going to finish up with the last problem here. So what is the value of x for this scenario? All right, so first off, well, we know that this is 49 degrees. So by vertical angles, this has to be 49 degrees as well, because those are vertical angles. They are formed by two intersecting lines, and they're opposite of each other. Okay, so those are considered to be vertical angles. So we got 49, and so now we know that we know that this is 49, this is 127. So we're trying to figure out x here. So this right here is an exterior angle of this triangle, right? So this is my triangle, and this is my exterior angle. So to get that exterior angle, right, I have to add up my two remote interiors, and my two remote interiors are this angle and this angle. 49 plus an unknown. How do I get that unknown? Well, I do know that 127 and this angle add up to 180 because they form a linear pair. So I can technically find this. So that's what I'm going to do here. So 127 plus this angle add up to 180. 127 plus, we'll call it y. We'll call this angle y. Just because we already have x taken up. So subtract 127. And so this unknown variable, which we called y, is equal to 53 degrees. So we know that this is 53. And so if we add 53 and 49, we should get this exterior angle. So we'll go ahead and put that in here. So 49 plus 53 has to be x. So we have 12, 1, 5, so it's 102 degrees. All right, so that's my value of x. All right, guys, that is going to be it for the video. I think, let's double check this answer choice. We got 102. All right, that is it for the problems, guys. That is about 12 problems. We technically did 11 because one of them was a copy. I hope you learned something from this video, and as usual, I'll see you in the next one.